James Titcomb. Nice to see you all here, wide and awake, ready to learn things. And I'm going to tell you about RabbitMQ today. I've been doing PHP for like 12, 13 years. I'm Zen certified engineer, which makes me pro or something. I run the PHP Hampshire user group down on the south coast of the UK, if you're not from the UK. I'm also starting a conference with a load of buddies called PHP South Coast, hence South Coast. It'd be great if you could come along to that as well, learn more things. We've got some great speakers. Anyway, I am the development manager at a place called protected.co.uk. And for the context of this talk, what the sort of things we do there are just in-house products. So we make like a CRM, tracking, analytics systems, and the website itself. So let's move on to the talk. What is message queuing? Well, in its very simplest form, a message queue is something where you can put a message in, it puts it in a queue, and something else takes it out of the queue, right? So we're all fairly familiar with really simple queues. For example, an array is a queue. When you use something like RabbitMQ, it's quite nice because a term that I actually first heard from the guy sitting here was fire and forget. And that means basically you give it a message and you can forget about what happens to the message once it's in the queue. So the fancy term for this is message-oriented architecture. And it's in concept quite similar to something you may be all a little more familiar with, which is service-oriented architecture. These are big words, and it's first thing in the morning, so I apologize. What it means is you can asynchronously process data, but you get a synchronous acknowledgement that that data is going to get processed. So, agreement that this data is going to be processed later. It allows you to separate your concerns. So, one of the beauties of RabbitMQ is that you can use it with loads of different languages, PHP, C#, Java, Node, anything. Anything that talks AMQP. Which stands for Advanced Message Queue Protocol. And this is an ISO standard protocol now. It was, in the last year or so, made into a real standard, if you like. And it's an open protocol. So not just RabbitMQ speaks AMQP, but that's just one broker, message broker, that does. So by separating out your application, a real benefit that you're going to get from this is that you can scale parts of your applications separately, which is really cool. And the separation allows you to do background processing while your front end, for example, our website, carries on just serving up web pages. And then in the background, we've got something processing lots of data, making reports, whatever. And the reason that happens and works so well is because you only have to wait for the message to be queued. You don't have to wait for that data to be processed. And that allows you to scale. And let's have a quick look at how. So, say, for example, we have our front-end application over on the left. We're putting messages into a queue at a rate of 5 per second. Now, our background processor can only handle 1 per second. It's a bit slow. It does something slow. Every second, 4 messages are going to build up, and the queues are going to fill up pretty fast. So what RabbitMQ allows you to do is connect another processor, and another, until you reach a point where all the queues are being processed at the same rate as they're being put in. Now, this is a really linear, simplified example. And in reality, the number of consumers, depends on the average queue size, how actually fast you want the messages to be processed. Say you have a spike in traffic which causes all your queues to fill up, maybe it doesn't matter so much that the data doesn't get processed straight away because the spike in traffic is going to tail off, and then your messages can get processed after that event has happened. But if you do need that stuff to be processed really quickly, you can just connect more consumers. to process all this data coming through, right? And it allows you to scale to demand, if you want. And when you're looking at the queues and thinking, oh, they're filling up quick, you don't want to be doing that all the time, so you can use monitoring software like Nagios or something to monitor the queue size, check the throughput is fine and acceptable. Okay. So far it's fairly abstract, okay? What's some real-world uses? What do we use RabbitMQ where I work for? We use it for sending emails, because SMTP can be sometimes slow. We use it to send SMS messages, because they are a little bit slow sometimes. We use analytics and reporting through this system. So when we want a report to be run in our tracking system, that report request goes via RabbitMQ to be dealt with by the reporting server. We do data warehousing as well. So aggregating all our data into a much more sane format is all done in the background on these background servers. And also logging. All of our application does loads and loads of logging, and that's done via RabbitMQ. I'll show you a little example a bit later on of how that actually works. So, why RabbitMQ? It's a question I get asked a lot. And the answer to that is, well, it's really simple to start with. You can get up and running with RabbitMQ in not very long, maybe 20 minutes or so. It's really flexible, though, okay? So, yes, it takes not very long to get up and running and start understanding the basic concepts, but it gets really flexible. You can really scale up this system, make it as complicated as you like. And as I mentioned before, it's really scalable. And scalable is cool. And another thing is, say you use something, or you have experience with something called Gearman, which does a similar sort of job. I have no idea what's going on with the Gearman server because there's no user interface to it. You have to write things to inspect the queues and so on. RabbitMQ has a great plugin called the Management Console, which gives a nice web interface, which allows you to see what's going on much easier. What I would say is, use what works for you, right? If something very straightforward like putting a queue into a Redis instance works for you, that's fine. But you may find, if you scale your business, or your application rather, it may be a little bit restrictive. So RabbitMQ has this power to do this really simple stuff, but then when your business and application demands it, you can scale it up with the business. Okay, so let's install RabbitMQ. Let's get a bit more technical now. For all of this examples, I'm using a Precise64 Vagrant VM. You can actually download this. I'll give you the link in a moment. And it's really easy, okay? So using Ubuntu, you just add the Debian repository, sign-in key, apt-get update, apt-get install, you know the drill. So the second to last one is RabbitMQ plugins enable RabbitMQ management, and that's this management console that I mentioned. So I highly recommend you do that, because then you'll get your nice web interface, and you won't get too lost too quickly. And this is what that management console looks like when you first log in. It gives you an overview of everything. It gives you your number of queued messages, the message rates, how fast the messages are going through your system. You get the server information, so if you've got the number of processes, the number of connections, how much memory is being used, and so on. And if you've set up a cluster, because you can, we'll explain that later, you can see all the nodes in the cluster, right? If you don't understand what I'm about to explain, don't worry, because I'm going to cover off all the terminology that I'm about to introduce. So this is the connections list. See the number of connections. Great, cool. We've got quite a lot going on, apparently. This is the channels. So there's a distinction between connections and channels, which I'll explain shortly. And it caught me out, and it took me a while to understand, but I'll get to that. This is the list of exchanges. Again, don't worry, if you don't know what an exchange is, I'm going to explain it. And then you get your queues. We know what a queue is, right? You can view the messages in the queue, purge the queue, or basically truncate if you like. You can see what consumers are consuming that queue as well. Okay, cool, we've had a look at that. That helps you find your way around things really easily. So, let's dive into writing some code. Excuse me. Let's first look at a really, really basic example, a really basic message queue. If you want to follow along, point your laptop or phone or tablet at this URL now. All the code is there, and you can follow along with it if you like. So yeah, github.com/asgrim/rmq-slides. I shall pause just for a moment if you want to do that. Okay, moment's over. Let's have a look at things. Basic queuing, right? This is what we're trying to do. We've got something on the left, producing messages to be processed. Doesn't matter what's in them for now. And we've got something on the right that we want to process that data with. Okay, in all our examples, our data is just going to be a string. Like this is a test message or something like that. And this is how we're going to demonstrate the basic queuing, right? So, to start off with, we need to include some code to talk AMQP, the language that we need to speak. Now, I do this with this library from a guy called Alvaro Videla, and it's a PHP-written userland library. There is also a PECL extension, but I've not used it, so I don't know what it's like. I've just used this. You can include it using Composer, because Composer is awesome. Who doesn't know what Composer is? Cool. Excellent. That's really good. Yeah, if you don't use Composer, highly recommend it, because you can do things like this, Composer install. Great. Cool. So, this is the connection code. Now, imagine this precedes all of the examples I'm going to show you today. And this is pretty much the same for everything. The connection is really straightforward. It's just like connecting to a MySQL server, for example. You give it a host, the port, the username, password. The last parameter is the vhost. You can set up virtual hosts and stuff. We don't use that, so I haven't really played around with that much. So, the channel on line 6 is what you use to interact. So I've mentioned previously that there's a distinction between connections and channels. And I found this out the hard way when our application started performing really badly, because we'd opened lots and lots of connections. Turns out that's not the way to do it. What you need to do is open one connection, and then you can use these channels, which are like virtual connections, if you like, to open lots and lots of different message queues through the system. So just have one connection to one server, because otherwise you'll find your resources run out pretty quickly. I did that the hard way. Excuse me. So, the producer is where our messages are generated, created. We start off on line 3 by declaring the queue using queue_declare. It's really ingenious naming. I love it. So we've got a few arguments going on here. The first one is the name of the queue. The next one is passive, durable, exclusive. I don't have to worry too much about what they are, okay? The last one is auto-delete, which is basically when you disconnect, the queue will automatically get deleted. In our example, we're not going to auto-delete the queue, but you can if you want. So on line 6, we create the actual message content itself. Now, as I said, the actual content of the message can be anything you want. We use JSON because it's fairly interoperable, and we have some backend processes that run Node.js. It can be anything, right? You can put binary, base64, whatever you want, okay? And you just pass it as a parameter to this AMQP message object. And then we use the ingeniously named basic publish function on line 7. You give it the message object that you just created. You give it the name of an exchange, which we're going to leave empty for now because we don't know what an exchange is, and a routing key. In this case, the routing key is just the name of the queue that we're going to send the message to. Test queue. And this is the other side of the coin. This is the consumer. Now, again, the connection code imagine that's above this. I just can't fit too much content on a slide. And the consuming, as you can see, is done by creating a callable. So that can be a static function. It could be an anonymous function, as I've written here. And you call the basic consume method and pass this callable to it. Again, there's a few parameters here. They are the name of the queue that you want to consume, an identifier, so that's an identifier for you, the connector. It's sometimes useful. I've left it blank here. And yeah, the most important one, the last parameter is the callback that you want to process. And this callback gets executed every time a message comes in. So this function deals with each specific message in however way you want to. The last bit of code is the channel wait, which is a blocking function that basically waits for a message. And we have a while loop that makes sure that a callback is still registered. If it's registered, it will carry on looping and waiting for messages. So as you can see here, this turns into a long-running process. Okay? So if you feel uncomfortable with that, maybe use a different language, I don't know. But I think PHP now is fine for long-running processes. We have all ours, most of ours, rather, running PHP. And you can do things like interact with signals. I highly recommend, if you want to learn a bit more about signals, check out a book called Signaling PHP by Cal Evans. That's great for long-running processes. Or you can just use Control-C to quit the process, whatever. Okay, so if we run this particular code, this is what it's going to look like. The background window here is the consumer, and the foreground is the producer. Each time we run our code on the producer, we generate my test message, and in the consumer, you can see it being echoed. It's really straightforward. Okay, let's get a little bit more complicated. We're going to learn about exchanges now. So I've mentioned them a few times. And we're going to first look at a type of exchange called a fan-out exchange. So this is what an exchange might look like. Now, a fan-out exchange is characterized by the fact it sends the same message to all connected queues. So it duplicates it, if you like. And the consumers could do different things with the messages. Take a logging scenario. One of these consumers could send the log messages to a MySQL database for storage. Another one could examine the message and determine whether maybe it's a critical system error, in which case it might send an email to you or SMS message saying something's broken, something like that. So we can do different things with different consumers, which is quite cool. But the message is only sent once. You don't have to send it for each different thing you want to process. So that's what a fan-out exchange does. We're going to write one now. In this, the producer code is actually a little bit simpler. If you look at this slide carefully, you'll notice that we don't actually mention a queue anywhere. And the reason why is because we leave the queuing up to the exchange. The exchange decides where to put the messages. So instead, we call exchange declare function this time. Similar sort of parameters. The main ones is the name. That's the name of the exchange that you want to publish to. And then we call basic publish, just like before. Create the AMQP message object. And we publish it this time to test exchange. And we've omitted the last parameter. So before we put a routing key of test queue, which was the name of the queue that we wanted to publish to. This time, we're omitting that. We're just saying, send this message to test exchange. And that's it. So the consumer here, the other side of the coin, is a little bit different. This time, we're calling queueDeclare, but we're not actually giving it a queue name. Okay. $Q open square bracket 0 is the resulting queue name. So what RabbitMQ does here is it generates a temporary queue name. And it returns the name of that queue. Great. In this example, I've set the auto-delete parameter that I mentioned earlier to true. So RabbitMQ, when this consumer disconnects, will delete that queue. And same as the producer, we call exchange declare, with the name of the exchange, obviously. And once we've done that, we can do something called binding. And what we're doing is we're binding this queue to the exchange. Okay? The rest of the code is the same as before, so I've omitted it here. It's the while loop, and that's pretty much it, and the function and everything. Okay? So this is what we look like here. The produced messages, 1 and 2, are produced when there's no consumers running. The messages went nowhere. We connected the first consumer, the top one, and produced messages 3 and 4. And they were consumed only by that one consumer. And then we connected a second one, the bottom of the background windows, and produced messages 5 and 6. And notice that they were consumed by both queues. So as I mentioned earlier, those messages fanned out to both consumers via the queues. Cool. Just a quick word about temporary queues. As you may have spotted already, they only listen to the current flow of messages. So if you've not got any consumer connected to that queue or exchange, then the messages just disappear. Now, in some cases, that works for you. For us, we like to have all of our messages, so we don't use temporary queues. It depends on your use case, right? Most of the time, as I said, we use what is called shared or non-exclusive queues. And that allows the messages to build up in the queue while no one is consuming that queue. So it depends on your use case. Okay, another type of exchange is a direct exchange. They're pretty cool. When you produce a message, you can give it a routing key. Now, thinking back to our first example, we've already given a routing key, so we've actually already used this concept before. A routing key is like an address, a postal address. An exchange is the sorting office, except maybe a little bit more reliable than Royal Mail. The queue itself, think of that as the delivery person, right? It's delivering to the consumer. And by using this routing key, it gives you a huge amount of flexibility about what happens to a message. We'll have a look. Well, if you send a message with a routing key of orange, it's going to go to the queues that are looking for oranges. So you can see on each of the queues I've labeled what sort of messages the queues are looking for. Now, the first queue is looking for all sorts of things. So if we send a message with orange, it's going to go in the first queue. But notice it doesn't go into the other queues, because they're not looking for oranges. If you have a banana, it's going to go to the first and second queue, because they're both looking for bananas. And apples, as you might have guessed by now, it goes to all 3 queues. They're all bound. So I mentioned this binding thing earlier. It's binding to that routing key. And we call it, when we do the actual binding, a binding key. Cool. All right, so this is the producer. The only real change from our previous exercise is that we've now put the routing key in. This particular script, if you're looking on GitHub, obviously it runs on the command line, and I've passed this routing key in via the command line, which we'll have a look at in a moment. So thinking back to the original example, remember that we had a routing key which had the queue name. And, well, why did we do that? Well, it actually worked because RabbitMQ will default to using an internal exchange that is already set up. We obviously didn't specify an exchange name, if you remember. And it forwards it to the queue that matches that routing key. And that is how that worked in the first instance. So this is the consumer. The biggest change here is that there is a queue bind per routing key. As I mentioned, that's called a binding key. If we ran this particular code, we would receive all messages with a routing key of apple, because we've bound it to apple on line 7, orange, and banana on the following lines. So we're listening to lots of different types. So let's have a look. In this example, I run 3 consumers, and the consumers are on the left. The top one, is looking for apple, banana, and orange. The second one is looking for just apple and banana. And the last one, just for apples. If I produce messages on the right with each individual key, you can see it processed by the appropriate consumer. Cool. That's pretty cool. So we now have an address on our messages that define where these messages go to and how they get processed by RabbitMQ. But there's more. There's another type of exchange called a topic exchange. And it's pretty much the same, but we've introduced a new concept to the binding keys. We've introduced the asterisk and the hash, or pound sign if you're American. And they have specific meanings. So an asterisk matches exactly one word. Now, a word in a routing key is basically a separation with a full stop, or a dot, or a period, whatever you want to call it. So an asterisk will match exactly one word in that string. And a hash sign will match 0 or more words. And just by introducing these 2 little characters, we've got a huge amount of flexibility now, even more than before. If we send a message to our queues here, red.vegetable, well, the first queue is looking for star.vegetable, so that message is going to go there. And the second queue is looking for hash, which is basically, I want all messages that are sent to this exchange. The last 2 queues, they're not looking for the right thing for this message, so they won't get that message. If we send a message green.vegetable with a routing key of green.vegetable, it's going to go to the third queue as well, because it's looking for green.0 or more things. Green.grass.long, the second queue is going to get it, because it's looking for everything. The third queue is going to get it, because it's looking for green.0 or more. And of course, there's 2 words following in grass.long, green.grass.long. And the fourth message is also going to get it as well. Now, I've included this last example to demonstrate that although both binding keys have matched the routing key here, the message doesn't get duplicated. So again, that's a question I get asked occasionally. So the message only gets put in that queue once, even though it's matched 2 different binding keys. If you, go on, got a question?
Why does it match the bottom one?
So the question is, why does it match the bottom one? Well, the bottom one is looking for star.grass.star, so that will match one word, .grass, one word, which matches green.grass.long. And the second binding key here is star.star.long. And that again matches. Okay, cool. So let's have a look a little bit closer at a real-world example that I mentioned we're going to look into. Logging. Oh, not that kind of logging. Okay, this is how it works on our website, okay? So an HTTP request comes in, an explosion happens. Oh, wait, it's just a little error, okay? Or a log message. And almost simultaneously, an AMQP message gets sent to RabbitMQ. There's a slight wait, obviously, for that message to get queued. And the HTTP response can be sent straight back to the website visitor. And notice that the message hasn't reached the log server yet because we've put it in a queue. So later on, potentially after the request is finished, if the logging server was busy or something, the logging server can then fetch the message and store it in a database or do whatever it wants. So that's how it allows you to have a huge amount of flexibility. Just with this really basic setup, we can use this sort of flexibility to, say, create a consumer that logs to the database, create another consumer that filters off critical messages and emails them or sends a text message, create a temporary queue to temporarily inspect debug messages, for example. So yes, you could leave debug in your production code, perhaps, and ignore it for most of the time, but just create a temporary queue to listen to that if something's gone wrong, for example. And you can get really creative with those routing keys. So say, for example, you have a log message with a routing key of app.api.error that describes that there's an error happened with our API, for example. Then you could listen to those messages with a binding key of hash.api.error. And it would pick up all the API errors. A routing key of, say, if you send a message with the routing key of app.form.debug, and you wanted to listen to all the debug, you just create a queue hash.debug, and it just listens to all of the debug messages. It allows you to do lots of parallel processing. Now, note in all of the diagrams that I drew, there was only one consumer per queue, but thinking back to our very first diagram, there was lots of background processors or consumers listening to one queue. And that allows you to process lots of things in parallel. You can have many consumers per queue. Now, note, when you do this sort of setup, the message will only get processed once, unless it's put back in the queue. For example, you reject the message and say, I don't want to process this, or your process dies. There was an exception or something that killed PHP process. And that allows for spreading out the load. You can do many things at once. But there's a bit of a caveat. You need to be aware of external factors. Now, there was a time when I decided to put sort of 2-3 million messages into a queue, which is fine. But then I noticed lots of errors happening. And the errors were actually MySQL deadlocking because I was trying to process way too much at once. And MySQL couldn't keep up, so it kept deadlocking because we use InnoDB, and so there's these things that happen. And I found out that actually there is a critical mass for the number of consumers for that particular background processing I was doing, and it was about 16. So I could only process 16 things at once. That's fine. It took a while to get through those few million messages, but... Okay. So I mentioned you can reject messages, and similarly, you can also acknowledge messages. So by default, well, it's an option. You can either automatically acknowledge messages, or you can manually do that. Now, if a message does not get acknowledged, it could get redelivered to another consumer if your process dies, which is a bit weird. So if you forget to put in your acknowledgement call, your message acknowledgement call, and your process dies because it's an exception or something, then all of those messages that you processed but didn't acknowledge are going to get put back in the queue by RabbitMQ, which is a weird thing to happen. So if you don't want to automatically acknowledge messages, make sure you acknowledge them appropriately. I'm going to talk about a few features of RabbitMQ. Another question I get asked sometimes is, well, how do you get response? So looking back to our logging diagram that we did with a website message error, obviously we don't know that that has definitely got stored in the logging database because the request has already ended by that point. Well, one way to do this is RPC, remote procedure call. The client sends a message to your Exchange or queue with a parameter, an extra parameter called reply to. And that's the name of a queue that it's going to reply to. So you send this message, and then you listen on that queue that you just told it, I want a response on. So the other side of the coin, the consumer, it listens just like normal. It does the work when it receives the message, and then it sends another message back to the reply queue. So that the producer then says, oh, okay, I've got this. Obviously, it's a blocking process, so you need to figure out your use case there. Unfortunately, when I first started playing with RabbitMQ, I was like, oh, this is really cool, and then I forgot to read the rest of the manual, and I did it a slightly different way, which is not the best way. But we actually do a similar thing to how RPC works. When we send a message into the queue, we have an HTTP URL that we include in the payload and say, this is where you send your response. So once our workers have done some work in certain cases, we'll send a response to that URL, form of a post packet, for example, saying, this is the data I've processed. And then we've got a web service that listens on the other side for those responses. Now, there's actually another way of doing it that I thought of, and that's to store it in a database and have your producer poll the database, for example. Fairly similar in concept, just slightly different executions. TTL, or time to live. If you're familiar with DNS, DNS has a TTL, similar sort of concept, right? Now, there's three types of TTLs in RabbitMQ. The first is a per queue message TTL. That's a mouthful. And that basically means all messages that get put into a queue that has a per queue message TTL, they will have the same TTL, or time to live. So those messages will drop out the bottom of the queue after 30 seconds, perhaps. There's also a per message TTL. So when you send an individual message, you can set a unique time to live on that message. And so that allows for lots of different times for each individual message to fall out the bottom of the queue. What do I mean by falling out the bottom of the queue? Well, that message just doesn't get processed because you didn't process it in time, for example. Now, you might think, well, that's a bit odd. Well, if I put a message in a queue, surely I want it to be processed. Well, maybe not. Again, like I said, it depends on your use case. We have TTL on some submission processes. We send leads to a third party, and in that submission, we run a cron every 2 minutes. So we put a TTL on the messages there of 1 minute so that we don't overflow ourselves and try and send the same thing twice. There's also another type of TTL. I said there was 3. The other one is a queue TTL. And this is actually a time to live on the queue itself. So the queue will self-destruct after however long you tell it to. I've not come across a use case for it, but going back to what I was saying earlier about the flexibility and scalability and things, this is one of those things where maybe I have this edge case where I want to delete queues after 10 seconds or 30 seconds, whatever. So you can do that if you want. Now, TTLs work really well with something called a DLX, or a dead letter exchange. Now, a message will be dead lettered if a message reaches its TTL, so it falls out the bottom of the queue, and or the consumer rejects it, so you can say, reject this message, I don't want to process it, and you've turned off requeuing, so there's two requirements there, or the queue length limit is exceeded. Now, normally queues don't have a limit, but you can put a limit on a queue if you want. And so I mentioned if a TTL happens, or these other circumstances happen, the message falls out the bottom of the queue. Well, a dead letter exchange is something that catches those messages. So a dead letter exchange is just a normal exchange, and the messages go into this exchange and into another queue. So a common use case for this that I see in the wild is that you want to delay the processing of a message. Say, for example, you have a webhead with a MySQL database and a data processing database. We have SQL replication from the webhead to this reporting server. And AMQP is much faster than SQL replication. So what we could do to overcome that issue is use a combination of a TTL and a DLX. So when you send a message through, you could say, this message has a TTL of 5 seconds. And after 5 seconds is up, that message will drop into the dead letter exchange and go into a different queue. And that queue is the one you listen to if you want messages delayed by 5 seconds, which is useful in some cases. So you can try all this out. as a concept, if you like, without getting too technical, in fact. Try RabbitMQ.com has a RabbitMQ simulator. And basically what that allows you to do is draw pretty diagrams using the concepts in RabbitMQ. And you can send messages through it and see how they react to binding keys, messages, TTLs, and things like that. So you can actually have a play around with the abstract concepts introduced by RabbitMQ. Okay. One more thing that I'm going to talk about today is about infrastructure. The astute among you might have noticed there's a single point of failure. Well, what happens if RabbitMQ server dies? Well, it's fine, because we've got this thing called clustering. I mentioned it way at the start. And you can create a cluster of RabbitMQ nodes. And it tolerates the failure of one or more nodes up until there's one left. And when you have this sort of setup, I recommend using like a load balancer or floating IP, low TTL DNS, something like that. Don't connect to a node directly. Let something else deal with that for you, so that you know that the node you're connecting to is going to be up. So when you set up a cluster with RabbitMQ, everything is replicated that you need to operate the cluster, except for the queues. The queues themselves are not replicated. They only reside on the node that they were created on. But they are accessible from any node. So if you connect to the wrong node where a queue isn't stored, it's OK, because the messages still get to you. So it's a sort of a transparent process, if you like. But that's something to be aware of. There's two types. There's a disk node and a RAM node. A disk node writes all of its queues both to RAM and to disk, so it always goes into RAM. A RAM queue performs very marginally better. You'd think it would be a lot better, but actually because a disk writes to RAM and disk, the difference there is not much. I'm going to mention something about a high watermark. This caught us out. With memory limits on a server, okay, so we have a message queue server with 1 gig of RAM. Now, a high watermark is basically a setting in RabbitMQ that allows you to set how much memory to use for RabbitMQ, okay? What caught us out is it, by default, uses 0.4% of your memory. So on our gigabyte server, which we thought, oh, gigabyte would be fine, it was actually only using about 400 meg. And I noticed that at the same time as then I put those 2 or 3 million messages in. Oops. And that broke things a lot, because once your RabbitMQ server reaches that high watermark, it will stop accepting new messages. So the website went down and everything. I was in trouble. So configuring a cluster, let's have a quick look. You can use a CLI, a tool called RabbitMQ-CTL. It's a little bit easier, but if the entire cluster dies, you lose all your configuration. So probably a safer way is to use configuration files. The format's not great. Looks a little bit like this. There's lots of square brackets and curly braces and things like that. So this is on our dev machine. Notice the high watermark I've changed there. And if you're ever not sure about how to write these configuration files, just stick some curly braces and square brackets in. No, that won't work, by the way. Don't bother trying. So to set up this cluster, well, first of all, we can use the cluster status command to inspect the state of the cluster. If we were to run this on each node, you'll notice that they only are aware of themselves. They'll only show themselves on each node. So let's create a cluster. To join a node, you use join cluster command. On our first one, we specify --RAM to make it a RAM node. If you omit this, it's a disk node. And the last parameter here is the host name of any existing node in the cluster. So it doesn't matter which one, just join it. They're all equal in this cluster. There's no masters. And the second command, for that reason, could be written as RabbitMQ-CTL join cluster rabbit at node 1 or node 2, doesn't matter. So if we run cluster status after this, you'll see that all of the 3 nodes are now joined into the cluster. We've made a cluster. It's as easy as that. Obviously, do this in configuration. Starting and stopping nodes is easy. You can restart nodes at will. When a node is not running, it will not appear in the running nodes section in cluster status. They will automatically reconnect if you start and stop. Removing nodes is a straightforward process too. First of all, you stop the node you want to remove. Then, on any existing and running node, you use the forget cluster node command. Now, when you bring node 1 back up, it will have an error and say, oh, I can't connect to my cluster because it thinks it's still in a cluster. So you have to reset it beforehand. And finally, if you run cluster status, you'll notice that node 1 was removed from the cluster. OK, so I mentioned that queues are not replicated. It's cool, they've got a solution for that too. We use this. High availability. It's typically you probably use less nodes, so it tolerates slightly less failure, but I've never had a RabbitMQ server go down on me that wasn't my fault. I still recommend the load balancer or floating IP, things like that. But the big difference here is that queues are replicated. So it copies the actual queue messages to all of the nodes. And to do that is really simple. You set up a cluster first, and then you use a set policy. You can do that in the management console, the web interface, to configure these high availability parameters. Now, the actual syntax and things for that, I don't know, because I didn't do. Someone else did. So, as I mentioned, you can have a go yourself. Some of you may have been following along with your phone, looking at the code. And you may have noticed that there's a Vagrant file there, and instructions to get set up. So you can actually play around with the examples I've given anytime you want. Go here, yeah, here, and clone the repository. Obviously, you'll need Vagrant, or use the instructions on a server. OK. Thank you very much. Are there any questions?
Actually, I was just wondering, can we ask one question up front? How many people have actually used a queue server at all in their work before? Mind me hands. I'll just check the other room as well.
Cool.
How many of you guys as well? OK, and how many have actually used RabbitMQ itself? OK, so it's about 80% have used queues and about 50% have used Rabbit. OK.
Cool. Interesting.
Guide. OK, so question 1.
Hi, I have one question. How you solve versioning of your messages? Let's. Do you understand this question, or I should describe more?
Say it again.
How you solve versioning of your messages?
Versioning?
Yeah. Well, you deploy a new version on server. You have some old messages in queue. Then new appears, and you restart your consumers. So how you deal with that?
OK, so I understand, yeah. So if you send a message and you've still got your process running, well, that process is still running. Obviously, the code hasn't changed because PHP does not, hot code swap, I think they call it. So actually, what you can do is leave your processor running once you've deployed your code. And yeah, if you leave it running, then it's still going to process those using the old code. So when you deploy it and you're happy that all the messages have been processed successfully, then you can kill that server, that process, and start the new one with the new code. Typically, I've not really done that. Maybe one way to do it is if you don't care about the content of the queues, you could purge them, which obviously deletes all the messages in it. Depends how sort of violent you want to get with it, I suppose. OK.
We'll take one from this side. Any questions in this room? Yeah, OK.
Yeah, the question is, when you do clusters and you join nodes together, there's anything in RabbitMQ that actually deals with connections and network faults?
Now,
like if the replication doesn't happen or something?
Yeah, network faults are an interesting one. RabbitMQ is not very tolerant of network faults. So their recommendation is that you don't replicate across potentially a wide area network. So the better way of doing that is to use a plugin called Shovel. Now, Shovel basically takes all the contents of a queue and moves it to another server, shovels them from one to the other. So if you wanted to replicate across the internet, for example, I'd recommend doing something like that. Does that answer your question? I can't see him nodding, so cool, thank you.
I'm wondering, when you use a routing key together with a topic exchange and you have multiple consumers, and for example in that 1K you have 3 consumers that can take the same message, would all 3 consumers receive the message, or might only 2 or 1 of them receive it, depending on where they are in the cycle, if they're only already processing and so forth?
So if you have multiple consumers connected to one queue, the message will only get processed by one of those consumers. So the other consumers won't be aware of it. The only way that a message could be duplicated is by using binding keys on different queues, or using a fan-out exchange with multiple queues attached to it. So when you have multiple consumers on one, it will only see the message once. But if you duplicate that message out, you'll see it multiple times.
Okay, so in that case, if you, for example, with the example you did with logging,
Yep.
if you need to make certain that, for example, if it's a severe error, that is only handled by that consumer, and then that consumer again logs it to this database service like the normal logger would do.
Yeah, so I mentioned earlier, so we have a submission system which submits leads to a third party. Obviously, we don't want to send that lead multiple times, otherwise they'll complain that we keep sending them the same lead. We are just careful about how we architecture that. So we, as I mentioned, we use a TTL to make sure that we don't queue the same message twice. So yeah, you just need to be aware of how it works in order to overcome, duplicate submissions, for example. I think that's the best way.
Thank you.
Okay, we got one in the other room.
If you use temporary queues and turn off acknowledgements, what's the maximum kind of throughput that you can look at using RabbitMQ in messages per second?
It's limited by memory and just how fast the server is. Turning off acknowledgement on or off doesn't make that much of a difference to throughput. But if you don't acknowledge those messages, well, as I said, you can have weird scenarios where your messages start getting reprocessed. So throughput of any part of RabbitMQ is just limited by your network speed, how fast the server is, and so on. So it just uses the resources available to it. Does that answer your question?
That's a yeah.
Cool, thank you.
Have you got one, Aaron? No? Okay. We got one in the other room again.
Hi. Are the queues always first in, first out, or is there anything to change that or to prioritize messages so that, for example, in your logging example, there might be a high priority error that you would deal with first before some low-level debug messages?
I don't know for sure. There may be a prioritization mechanism, but I don't know. It's a good question. Thank you, but I can't answer it. Someone suggested in here that you could use routing keys for that. So yeah, that's one way if there isn't a prioritization feature. I don't think there is. I've not come across it. Aha, there's a priority plugin, apparently. Okay. So yes, it's possible with a plugin then. Thank you. Thank you for helping me out with that one.
Let's check the other room. Any more in here? Anyone else?
Got one more in here.
You got one?
Hi. When you're declaring all the exchanges and the queues, do you have to keep track to declare them exactly the same in both the producer and the consumer?
Yes.
Seems like there's nowhere to store that configuration.
Yes, that's the names of the queues and things are controlled by your code. So if they don't match, then they're not going to produce or consume the same thing. You could store it in configuration or hard code it. It's that's an application architecture thing. So yeah, they need to match obviously, otherwise they won't do what you expect.
It seems like, yeah, compared to like building a database, you can't kind of build the schema and then start using it. You have to kind of do both.
Yeah,
things.
indeed. For our application, we store the name of the exchanges and the queues in array configuration. We use ZF2, and ZF2 love arrays, so we store the names of the queues and exchanges that we use in there. And we've got that same configuration on both the producers and the consumers, so that is shared code, if you like. That's one way of doing it.
Hi, yes. In the RPC example that you gave, where you had a reply to
Yep.
feature, does that reply, is that queue that it sets up kind of like a one-off queue that's just for replying to that particular consumer?
Yes, absolutely. I didn't give a code example there, but when you're listening for the message there, you might not have that while loop. So you would just listen for one message, then quit. Yeah. So.
Okay, I got another one over here. 1 second.
If you said acknowledgements are like a sort of a message completed message to the queue, so the message doesn't get picked up by another consumer. If the acknowledgement isn't set or isn't sent, then the same message could be picked up again by another consumer. So, is there some locking mechanism? So if, how do I put this?
I think I see what you mean. So if a message is currently being processed, will any other consumer
exactly.
be able to? No. So RabbitMQ will only send the message once. So when you don't automatically acknowledge and you forget to acknowledge that message in your code, the reason it builds up those non-acknowledged messages is because RabbitMQ only tries to process things once by default, if you like. So if you don't acknowledge those messages, it sort of holds them in limbo, if you like. They're still in the queue. If you look at the management console, it'll say there's unacknowledged messages. And the reason why they get reprocessed is because when the process dies, RabbitMQ knows that that connection is closed. So it says, oh, well, all of these messages haven't yet been processed. So I'm going to put them back in the queue for another consumer to process. So while it's being processed, no, it can't get re-queued, if you like. But as soon as your process dies, like exception or error or something like that, then it will get re-queued, but not at the same time. I hope that answers the question.
Is there no way to put that in some kind of other queue, like a garbage queue, so you then have another consumer that then checks to see whether it really did complete that?
So the comment for those in the other room is that is there a way of putting those into a garbage collection queue or something like that? Possibly, I don't know.
I think I can answer that one. I've done that. Yeah, if you have messages that go onto DLX or onto a failure state, you can definitely requeue them onto another queue and have other consumers deal with that kind of garbage.
That was
So, yes.
I did explain that. Yes.
Yeah, you can absolutely do that.
If you reject a message or something like that, yes,
Yeah.
you can tell it to go to DLX.
We often set up